Greetings, students. You have one job. You have one job and one job only to do, and that is to copy down what I'm doing and then hand it in at the end of class. And that's it. Okay, what are we doing? We're doing 5 problems where each of these is going to say, each of these is going to have either a solution, which is nice, or it's going to have no solution, which is less nice, or it's going to have infinitely many solutions, which that's up to you to decide. Okay, we're going to go through. All right, here we are. Number one. 4 times 2x plus 1. Mamma mia. Okay. So step one, always, 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 if we can distribute, we're going to distribute. So we have 4 times 2x and then 4 times 1. So let's distribute first. 4 times 2x is 8x. That's pretty good. And then 4 times 1 is 4. Now, on this side, it says 5x plus 3x plus 9. Now, technically, step 2 is you should combine like terms. But why don't we just combine like terms here? So we have 5x plus 3x is, oh man, that's an 8. 8x plus 9. Okay, we have a couple of choices here. Do we want to keep solving this and figure out what x is? Do we want to say there's no solution? Do we want to say there's infinitely many solutions? And what I'm seeing here is that we have 8x on both sides. But over here we have 8x plus 4 equals 8x plus 9. So I always give this example, but let's say that Mr. Holland and Mr. Weiss have 8x dollars. And then you give Mr. Holland $4 and you give Mr. Weiss $9. Who has more money? Well, it's pretty clear that if they started with the same amount of money, 8x, and one gets 4 more and one gets 9 more, then they don't have the same amount of money anymore. But this equation is saying that they do. So there's a problem. You can't have 8x plus 4 equals 8x plus 9. Whatever 8x is, you can't add 4 to it and then have it be equal to 8x plus 9. So when we get to a problem like this, we say there is no solution. And if you really want to convince yourself of this, you could subtract 8x from both sides, which is fine. You can subtract 8x from both sides of the equal sign here. 8x minus 8x cancels out, and you get 8x minus 8x cancels out over here, and you get 4 equals 9. That's obviously not true. So there is no solution to this kind of equation. It would really be. Number 2. 12 plus 4x minus x equals 9x plus 6. Okay, so step 1 would usually be if there are parentheses, then you would distribute. But there's no parentheses in this one. So step 2 is we're going to combine like terms. And you might notice that positive 4x and negative x are like terms over here. So we're going to combine them. This 12 doesn't combine with anything, so we just write 12. 4x minus 1x is 3x. And then on this side, we have 9x plus 6. So there's really 3 possibilities of what can happen in an equation. You could either have no solution, you could have one solution, or infinitely many solutions, which means any number you plug in is going to work. And this one, I can kind of tell, is going to have one solution. There's going to be one number that works. If there's infinitely many, it's going to be the same thing on both sides. Meaning, 2x plus 1 equals 2x plus 1. Then any number you plug in is going to work. If you had 2x plus 1 equals 2x plus 5, then no number you plug in is going to work. But in this one, there's going to be some value of x that works. And I can tell because the coefficients in front of the x are different on both sides. So to me, I can tell this is going to work. Like there's going to be some value of x that we can plug in that's going to make this work. So after we combine like terms, usually we want to move the variables to one side of the equation. And we have a 3x and 9x. And hopefully you guys know you should get rid of the term that's lower. So 3x, 9x, get rid of the 3x. How do you get rid of 3x? You subtract 3x from both sides. You don't have to do it this way, but it's actually going to make it a lot easier for us. So 3x and negative 3x cancels out. All we have is 12. 9x minus 3x is 6x plus 6. And then we want to move all the constants, all the numbers to one side. So we subtract 6 from both sides. That cancels out. 12 minus 6 is 6, and you actually get 6 equals 6x. Well, this is nice, because if you divide both sides by 6, 6 over 6 is just 1, so this is 1x, and 6 over 6 is just 1. So you get x equals 1. So there's one solution to this equation, and it's x equals 1. All right, number 3. So there are parentheses here. So generally when you see parentheses, the first thing you're going to want to do is distribute. And on the left side of the equation, I'm going to distribute this 5 times x and 5 times 2. And on the right side, we're going to distribute 2 times x and 2 times 5. 5 times x is 5x. 5 times 2 is 10. And we still have this negative 3x there. Then the equal sign, 2 times x is 2x, and 2 times 5 is 10. Now I want to combine like terms. And over here I see 5x and negative 3x. 5x minus 3x is 2x, and we still have this plus 10 here, so 2x plus 10 equals, and on the right side, we have 2x plus 10. So basically we have 2x plus 10 equals 2x plus 10. And you got to think, what value of x could you plug in here that would make this work? You could plug in 1, you could plug in 2, you could plug in 3. It's always going to work because the expression on the left is equal to the expression on the right. So it's always true. And when this is always true, meaning you could plug in infinitely many values of x and it would still work, we write infinitely many solutions. This means there's infinitely many values of x that would work to solve this equation. Number 4, and it feels like we just got started. Let's see here. Number 4. We have parentheses on both sides. So what does that mean? I think that means that we should get rid of that little stray red mark that I drew. And then I think we should distribute. Parentheses means multiply. We're multiplying 2 times 3x, and then 2 times 3, 3 times 2x, and then 3 times 2. So on this side, we have 2 times 3x is 6x, and 2 times 3 is 6. And then on the right side, we have 3 times 2x, which is 6x, and 3 times 2, which is 6. 6x equals 6. This is called an identity. It means that it's the same thing on both sides of the equation. And when this happens, it means that any value of x that you plug in will work. So there are infinitely many solutions. Any number you plug in for x is going to work. Infinitely many solutions. And the last one. 6 times x plus 1 plus 5 equals 13 minus 2 plus 6x. Okay, so we've done this a couple times already. So we distribute first on the left side. We have 6 times x plus 1. So 6 times x is 6x. 6 times 1 is 6 plus 5. And then on the right side, we have 13 minus 2x plus 6. I'm just going to leave that as is for now. And now let's combine like terms. 6x plus 6 plus 5 is 6x plus 11. 13 minus 2 is 11 plus, oh, this is an x, plus 6x. And you should recognize it's the same exact thing on both sides. Even though it's written differently, 6x plus 11 equals 11 plus 6x. It's the same exact thing on both sides, which means any number that you plug in is going to work. Now, I just gave you too many problems in a row. There were infinitely many solutions, so don't go anywhere. We're going to do one more bonus problem that looks a little bit different. Finally, it's that moment you've all been waiting for. I know you've all been clamoring for more math problems, so here it is. We have 5 times x minus 3 equals 9x plus 5 minus 4x. On the left side, I notice there are parentheses. I don't know why that just turned. Oh, I do know why, but I'm not smart enough to fix it. Okay, so on the left side, we have 5 parentheses x minus 3. So we're going to distribute 5 times x and 5 times negative 3. 5 times x is 5x. 5 times negative 3 is negative 15. Equals. On the right side, we have 9x plus 5 minus 4x. So we have 5x minus 15. What do we do after we distribute? We combine like terms. 9x minus 4x is 5x plus 5. What do you guys think? What's the answer? I'm not even going to tell you. Is this, there's one solution, there's no solution, or there's infinitely many solutions? All right, guys, think about it. Good luck. Godspeed.